Hi, I am Seshwini Gopal, and I'm going to show you how to write a Java application with linked lists without using a linked list object. Programming without objects is often useful, and is in fact the only option in popular languages such as C. What if you want special functionality that is not available in the linked list object you usually work with? Or what if you want to do one or two simple things with linked lists and don't want to deal with the overhead of using a full-fledged linked list object? In such cases, you want to spin your own functionality without having to write up yet another linked list class. In this two-part lesson, you'll see how. For background, you may want to view my lessons on imagining a linked list of strings and how to build a single node linked list in Java. And when you do, pay special attention to the memory representation of linked lists because memory addressing is a key element in this lesson. Okay, let's begin. Let's pretend we are keeping a list of movies we would like to see, and every time a friend recommends one, we add it to the front of the list. When we're ready to watch a movie, we pick the one at the front of the list and remove it from the list. Let's write an application class to do this with methods to add to the front and remove from front. Since our linked list nodes will store movie names, which are strings, I've defined a string node class out of which we'll create the node objects. Let's write our application in a class called movies. Okay, in the package linear, let's open the class creation wizard. The name of the application is movies. And let's make sure the main method option is checked. And click finish. Now let's use a variable called front as a pointer to the beginning of the list. And we'll define it in the main method like this. So front is a variable of type string node. And at this time, after you define front, it will be initialized automatically to null or the 0 address, signifying that there is no linked list yet. And as you can see in this picture, front is allocated memory at location 1956, and it holds the 0 address. Next, we want to write a method to add a new movie name to the front of our linked list. But before we start writing the code, let's visualize the process so we can get the logic worked out. The first step of the process to add a movie name to the front of our linked list is to create a new node for the movie. This picture shows a general situation where we already have a couple of movies in our linked list. A new node is created for the movie to be added and is pointed to by temp. The second step is to make the next part of the temp node point to the first node in our linked list so that Casino Royale precedes GoldenEye in the movie list. And finally, we want to update front so that it points to the Casino Royale node. Verify in this final picture that a traversal starting at front will hit Casino Royale first, then GoldenEye, and finally Die Another Day. So we've successfully added a movie to the front of the list. Now that we have a clear picture of the logic, let's return to the implementation. Let's write a method here, public void. I'm going to call this add to front. Now since the only access to the linked list is via the pointer say front to the first node, our method should get that front pointer passed to it like that, as well as the name of the movie that we want to add. And now I'm visualizing the process that we just went over, and I can match the code to the steps in the process. So the first step was to create a new node with the movie that was sent in and null for the next. So we have a node with movie and pointing to nothing else. The second step was to change the next part of temp to front. So now the new node points to the same node as front. And finally, we want to update front so that it points to the new node, which is the same as temp. Okay, so that was fairly simple, wasn't it? It really did help to sketch out the logic in pictures before going through the implementation. Now, speaking of pictures, we looked at the general situation where the linked list already had some movies in it. But what if it was empty? In other words, what if we were adding the very first movie? There would be nothing in the linked list then. Would our code still work? Well, we can find out by tracing our method statement by statement for this situation and seeing if it indeed does the right thing. Okay, so in the first statement, we create a new node. And here's what the picture looks like. The key difference between this and the general situation, of course, is that front is null here, since there is no linked list to start with. In the second statement, we're setting temp.next to front. Since front is null, temp.next will be set to null, which it already is anyway. So effectively, nothing changes in the picture. In the third statement, we are updating front so it points to the new node. This is exactly what we want, a single node linked list which has the movie we just added accessible through the front pointer. So the logic we implemented also works for the very first add when there is no linked list yet. Alright, we're ready to test our code. While we're pretty confident that the logic is sound, we need to run our program to make sure that it will work correctly. Now, just to check what's going on, let's go back to the main method and throw in a print statement here to see what would be printed out when you do this. So this should print out whatever is in the first node. Now notice here that Eclipse is giving us an error, and that's because it doesn't like the fact that we did not initialize front to null. So it says a local variable front may not have been initialized. This should usually work, but Eclipse is extra careful, so what we will do is to go back to that statement where we define front, string node front, and just set it to null to begin with. And that should take care of it. So notice that we did system out print line front, and what happens here is that it actually ends up calling the toString method in the node to which front is pointing. Now front is pointing to a string node type of node, so over here in the string node class, we had a toString method which returned the data, which would be the movie name in this case. And going back to movies.java, you could say front.toString explicitly if you wanted, and that would be fine. But it's actually more often the case that we'll just use the object name, and it automatically knows to call the toString method and print out whatever is returned. Again, just to repeat to make sure you got that, if you use an object name in system out print line, it knows to automatically call the toString method for that object and print whatever string is returned from that method. Okay, next, let's read a movie name from input. So to do that, I am going to set up a scanner object of the command line, which is system.in. Now, it's giving me an error because scanner is in a different package than linear. In fact, it happens to be in the package java.util. So what I'm going to do is I'm going to use a shortcut. And on the Mac, it's Command-Shift-O. And as you can see up top, it put in the import Java util scanner statement. Okay, once I have the scanner set up, I can prompt the user to enter a movie name that they would want to add. And actually I want to make this just system.print, so the movie name they add will be on the same line. And I will grab that line that they typed in into a string called movie. So let's look at what the memory looks like at this point. We have read in a movie name. We've initialized front to null. So in this picture, we're showing that movie has been assigned a space in memory right next to front. So it's at the address 1960. A movie object, the string Casino Royale, has been created at the location 2032, and the movie variable has this address. So the movie variable is pointing to the object Casino Royale. This assumes, of course, that the user entered Casino Royale when they got the prompt to enter a movie name. Okay, so let's go ahead and call our add to front method to add this movie to the front of our linked list. So front is the first parameter, and the movie is the next parameter. And it doesn't seem to like this. So there's a compilation error, and if you mouse over, it says cannot make a static reference to the non-static method add to front from the type movies. So what this really means is that this method add to front doesn't have a static in the header, whereas the main method is static. So the way to fix this is to also make the static. So the rule is that you can only call static methods from other static methods. And that fixes it. Before we run this program, let's throw in another print statement right after this to see if front got updated. So if all went well, then after adding the movie name, when we print it out, it should print Casino Royale, because that would be the first node. Okay, let's run this application. So we run it, and we're prompted for a movie name. So let's enter Casino Royale. Oops, it didn't work. So looking at the output here, we see that there's null that's coming from the front before we added a movie, and then we were prompted, we entered a movie name, and then this should be Casino Royale, because the front node should now have this movie. But that's not happening, so something went wrong. All right, well, we can try to find out what happened by tracing the execution using the memory representation of all variables and objects involved. And that should give us a clear sense of exactly what went on. All right, so let's start with a call to the add front method. When the method is called, front and movie are passed into it. The key thing to know is that the method add to front has its own memory space different from that used by the main method. So here's the memory picture just before add to front is called, which we saw a little earlier. Now here's the memory picture right when the method is called, but just before the parameter values are passed in. Notice that when the method is called, it has its own space that is set up. Front and movie are variables, which are the parameters to the method. And these have default initial values. So front, which is an address, has the value 0. And movie, which is the address to a string object, also has the value 0. Now make sure you understand that front and movie of add to front are local variables to that method, which are entirely different from the same named front and movie variables in the main method. Okay, so here's the memory picture after the parameters in add to front get the values that are passed by the main method. Now when the values are passed from main, they're copied into the parameters of add to front. So front in main, which is 0, gets copied into the front in add to front, which is 0, so nothing changes there. Movie in main, which is 2032, is copied into movie of add to front, which used to be 0, but is now overwritten with 2032. So the movie of main and the movie of add to front are both pointing to the same string object Casino Royale at the address 2032. With the copied in values, the method add to front executes the logic that we implemented. Here's the memory picture after the last statement in the method has finished executing, but just before control returns to main. Notice the changes here. First of all, the new node has been allocated space in memory, but notice that it's in a space area of its own. It's neither in the main method area or in the add to front area, because it is an object. Objects are not local to any method, but can be accessed from anywhere. The other change is the local variable temp, which has been assigned space in add to front at the address 1884, and it holds the address 2072, which is the address at which the new node has been assigned space. And finally, front, which had the address 0, now holds the address 2072, which is also the address of the new node that was created. So temp and front are both pointing to the new node, which is exactly what we had implemented. Now, after control returns to the main method, the space occupied by the add to front method is given up since the method is no longer active. And this is the picture of the main method's memory after control comes back to it. Notice that the picture for the main method reverts back to the original picture before the add front method was called. In particular, front has not changed, which means that the node that was added to the front is lost. Bottom line, values only flow in one direction from the calling method, which is main here, to the call method, which is add to front, as shown in this picture. So the change that was made to the front variable in add to front really had no bearing on the front variable of the main method at all. So when control came back, the front variable of the main method still retained its original value of 0, and we lost whatever change we made inside the add to front method. Okay, so back to the drawing board. We figured out that a change to a parameter front and add to front does not get reflected in the corresponding calling variable main. So how do we ship information back? Well, we can do it via return value. So let's redo the method to add a return value of type string node. So let's go in here and take out the void and make that string node. So what we're going to do here is to return the new address that we would place in front through the string node return value. And out here, in fact, we don't even need to change this. Kind of pointless to do that. And simply return temp. Since temp holds the new address, which is the address of the new node, it would get returned. And back up here, when we call add to front, we will have to update our front. So we send in the front, and the new address which comes back is assigned to the front variable. So it gets updated. Okay, so now let's run our program. Let's enter the movie name. And there you go. Okay, great. So we got that figured out. So to summarize, we have implemented an add to front method to add a new movie to the front of a linked list. We're not using a linked list object. Instead, we're sending the front pointer to the method, and we're returning the updated front, which is really the address of the new node, back to the main. Now there's a couple of things that we can add to this application to finish it up, but let's leave that for part 2. If you would like to test your understanding of what you've seen so far in this lesson, try this exercise. We can shrink the code in the add to front method down to a single line. Can you trace it with memory addresses and verify that it will work correctly? Remember, a new object call returns the address at which the object is located in memory. Okay, that's it for this lesson. See you in part 2.